I wanted to do a short video demonstrating how ChatGPT can give you the correct answer, but it does so in a way that your human brain just wouldn't do, because we don't have the level of memorization down that it does. It's able to just have all these numbers that it knows it associates with things, and it can just kind of use that as a resource where a human, we would actually have to do some calculations. So this was a question given to me by a student. It's kind of small, the writing, but they've given us a frequency of some metal foil where it's got that threshold, and we're wondering what light has enough energy to go and eject from this. So we're asking basically with that hertz or that frequency, what's a an appropriate amount of like wavelength that's associated with that, and which things have more energy than that. So I'm going to show you how it answers the question and then how I would actually go about answering this question. So we're really focusing on this problem 2 in the worksheet. The way ChatGPT did this is that it's like, okay, here's your frequency. I know all of these colors have these other frequencies. I would not have this memorized. I don't think anyone really does. I know that like light is around like 400, 700 nanometers. So I do have that memorized, just because you see that in biology a fair amount with visible light and, green light and photosynthesis and all that, right? So this question is basically cheating with how ChatGPT answers it. Um, it is able to determine that some of these things have enough energy just from these numbers. You're probably gonna struggle with doing that. As you can see, there's the green, the blue, indigo, and violet. These guys are having enough to eject, and then the red, yellow, and orange, those do not. But you might be like, wait, how does the frequency relate to the energy? And that's how I would actually go about answering this question, is thinking about this in terms of those nanometers that I know for the visible light and was actually also provided in the question. So I believe the teacher's expecting you to work with like the like 700 and like 300 400-ish nanometer numbers to calculate where are we when we have this hertz. So when I went through this question with a student, we were looking at the second one here, and I knew that there was that amount of hertz, or frequency, which we could correspond to a certain amount of energy. Now we also can use the speed of light formula here to figure out its wavelength. So we can just kind of plug those guys into those formulas, and we should be able to like solve for it actually. So we can, using that frequency, we can then say like how much energy is appropriate for that. But we could also use this frequency with the speed of light and just say what the distance of the wavelength would be. So if we have this 5.4 times 10 to the 14th hertz, and we know the speed of light is at 3 times 10 up to the 8th power, we can say like the wavelength for this thing should be 5.5 times 10 to the 6 meters. And then that's going to be like, I believe 550-ish nanometers. So if we know that light is around that 550-ish number, it's around this like 500 number on the visible spectrum, then that's kind of like the cutoff point. Now we know that the energy, if we have something that's more frequent, that's like more energy. So blue light has more energy in it than red does. So I know that like that's like my high energy end on the spectrum, and the red is my low energy end of the spectrum. So I'm able to say like, okay, these guys, they have more energy because they're on the high end. So all of these colors work. So by looking at this as a spectrum where we're lining up where the big numbers and small numbers are and like comparing that, that can be pretty useful. So the high energy here is also the high frequency, because we can see energy is related to frequency. So things that are more frequent would have more energy in them. Hence, ChatGPT's answer of these things having the higher frequencies working, this blue, green, and indigo and violet, that actually does make sense. But you need to give yourself some visuals and think about how the energy, wavelength, and frequency actually relate in some sort of visual display. Yeah. Way more clear with a human, right? But it's gonna get there. It's just gonna do things its own way until we're like, hey, can you solve this like a human would and explain it?